RAG malware project. In this project, what we've done is collected some relevant information on malware samples using the Malware Bazaar database, and we've passed a lot of data into vector embeddings, and we've also used our API key to retrieve relevant hashes that a user asks. But for example, if I'm a user, I want to ask an LLM about some information about a specific hash number that's associated with a malware sample. Well, depending on when it was released or what data the LLM was trained on, it might not know the answer. It might give me a wrong answer. So what we do using RAG is that we retrieve the relevant information. For example, if it's a hash number, we just use the API key directly and retrieve the information. But for example, if someone wants to say, "Oh, I want a malware sample that does this, and that," then what we can do is, using the user's prompt, we could pass it through a vector embedding, and then it will retrieve some relevant information, some relevant malware samples that follow the user's prompt. So that's what the project does. We've made some videos on how to run this program. We also have two UIs. One is a text UI that can be found in MB testing 3.py. But if you want to use a graphical user interface, which is like really cool, we have something called the RAG app. We have some documentation on how to connect this to the RAG app, and I would recommend using that as well. And anyway, I hope to see you guys in the next few videos. And if you have any questions, just feel free to comment. And good luck. And I hope you enjoy running this program and asking it some relevant questions about malware. Hello and welcome to the next part of the malware RAG video. Now, in this part of the video, we'll be discussing on how to gather our malware data for our vector database. Because we do have two databases that we'll be using. One is the simple API call, for which hash is mentioned in the user report. But we would also need a vector database to talk about, for example, if someone's describing a malware sample, we could put that query through a vector database, and it should give us some hash numbers that resemble the user's query. So how do we collect this data? Well, in the file called MB extractor continue, we could collect, for example, let's say 100 JSON files about, let's say, 100 JSON files that talk about 100 malware samples. Now, we have something called hashfill.csv. It should be called full CSV. I'll change that later. But it's basically a CSV file that has a lot of hash numbers, and it'll be going through each row that we tell it to, and it will extract like all the data from that hash number going through each row. That is weird. Okay, anyway. So like over here, you can see on line 58. And anyway, before I describe this code, hopefully you've read the documentation as well. Anyway, so line 58, for example, let's say I want to start on row like 5. Over here, I would say row 5, and then it would start collecting all the hashes from row 5 and continue. Anyway, that's enough talking. Let us run this code. Right now, I have it set to 74,000, but it will start on row 74,000. Let's see. Okay, sweet. So what's happening over here, I'm just going to close this call. What's happening is that it is opening the JSON file and just saving the outputs into a file called output.json. And as you can see, output.json has all the hashes that we just collected. And later, in the next part of the video, I'll show you how to use this JSON and put it through a vector embedding. Okay, thank you for listening, and hopefully you will watch the next video. Hello everyone, and welcome to the next part of the malware RAG video. In this part of the project, we'll be talking about how to embed all the data that we have collected. So now usually embedding takes a while, depending on which data set that you have. But in our case, I'll just be emitting one iteration of the JSON file. So like, I have a whole list of JSON, so it's just gonna go through the for loop one time, and that's gonna break and just return the text and metadata. I made some documentation, but if you guys, I can spin a bit up there right now. So what's happening over here is that this whole file called quadrant embed, it has some really useful functions. But for you guys, everything will be the same. Only difference is what you name your collection and just this one. So like, I'm reading data from JSON files from Malware. In your case, it might be just something else, so you can name it something else. In my case, I just named it read mbjson. But you have to have two arrays called text and metadata. The function will return those two at the end. But in each iteration, you're basically collecting the data for example, text. Text is the data that we're embedding into the vector database, and then the user question will be passed through the embeddings and like it retrieves the relevant information. The thing is, with embeddings, what if like I want some relevant information on those pieces of chunks? Then we can use metadata. So when it retrieves some relevant information, it'll also retrieve the relevant data as well, along with that. So over here you can see I'm just in this for loop, I'm gathering the text, and then I append it at the end. And then for the metadata, I'm just like appending all the information about this malware sample. Anyway, so over here in the main create collection, we already have one, so that should be fine. Text metadata, read mbjson, output JSON. So I have a folder called output.json. It's going to go through it one time, load embeddings. Okay, so let's run this code. Embed.py. Let's see. Oh, embed Python 3 quadrant embed.py. See what happens. Vector embeddings created, collection already is it, embedding successfully loaded. Sweet. So it was able to load the embedding successfully. For your guys, it might take much longer, and it should also say chunk this, like chunk 5 was put successfully, chunk 20 was put successfully, and yeah, but that's all you have to do. For my case, it took me like a few hours. Hopefully your guys is a bit quicker. But yeah, thank you so much for watching this video. Hope to see you in the next one. Hello everyone, welcome to the next part of our malware RAG video series. In this part of the video, I'll be showing you the text UI and how to interact with the malware RAG project using the terminal. We also have a graphical user interface, but for that you should read the documentation on how to clone the UI and set that up. But in this case, we'll be talking about just the text UI. Anyway, so let us run Python 3 mb testing 3.py. That should be in the main GitHub repository. Let's run that. I have a few questions. I have a list of questions that I want to ask it. Let us see which questions we will ask. Okay, welcome to the malware RAG app. Awesome. Let's see. Let me just go to my list of questions. Let's ask it a simple question regarding this hash number. Okay, can you give me the rules of this hash? Now it's asking, do you have any text files? In this case, I don't. Okay, I roll right. In the event that I did, I would upload all my PDFs into the main repository, and then I would say, okay, here's the file name. I'll give it the exact file name, .pdf as well. Okay, so this is some relevant context. This is the actual answer. Based on API. Okay, so it gives me 12 URL rules, and that's actually the correct answer because I opened the JSON for this hash number, and it did have 12 URL rules. Sweet. Would you like to continue? I do like to continue. You should write yes. For now, I have set up to write 2 to continue. Anyway, don't ask me why. But yeah, anyway, let's ask another question. This question that I'm about to ask it is really cool because it's going to use the vector embedding. So I'm going to describe the attack as a brute force attack, and I'm going to ask to give me the hash number. Okay, do you have any files? No, I do not. Okay, let's wait for the response. That was quick. Okay, after analyzing the provided data, I have found that this is related to brute force attack. Okay, awesome. And it gives me this hash. And we can double check this answer by going through our relevant data chunks. But yeah, this is some of the questions we could ask the Malware Rack project. I do encourage you guys to use the UI. In that case, for example, like uploading a file is much easier because you can just drag and drop. But yeah, just to repeat, this is using two databases. One is the API call. For example, if someone directly mentions the hash number, it can directly retrieve that relevant information. And if I just want to, like, for example, give it a report, you could analyze the report and tell me some simple questions about the hashes that are being mentioned using the vector embeddings. Thanks so much. Hope to see you on the next video, if this isn't the last. Hello everyone, and welcome to the Malware Rack project. In this part of the video, we'll be talking about the Malware Rack. So far what we've done in this project is using the Malware Bazaar API key. For example, in a prompt, if we talk about a specific hash number, we can get the relevant information of that hash and give it to the LLM and tell it to, like, hey, answer the user's question based off this relevant information about the hash. But another cool thing about this is we've also created a database full of malware information and their hash numbers, and we've embedded it. So, for example, if I want to talk about, hey, give me a malware sample that has these specific qualities, I would pass it to the prompt. The prompt would then be passed to a database, and any relevant information would be given to the LLM to answer that question. For example, if I have a brute force malware, I would pass it to the database, and we'll get all the malware hashes related to that prompt. Hopefully, if it works. So let's test it out. I have a few questions, so on this list, let's go with an easier one that uses the API key. Okay, malware, llama 3, 5. Let's see what it gives. Now, the cool thing with running llama 3 locally is that it pretty much keeps things private. It doesn't use or comparatively to Google's Gemini API, where we use their actual API on their servers. Anyway, so based on the provided data, it gives me 12 YAR rules. So can I give me the YAR rules of these? And it gives me 12, which is the correct number because I checked the JSON file. And it does have 12 YAR rules. Okay, sweet. Let's ask another question, which will not use the API key, but rather use our vector embeddings. Can you give me the SHA-256 hash that is about brute force attack? Let's keep it locally. Let's run llama 3. So in this case, it should give me a brute force. Okay, this is 7C. Okay, let's use the relevant context that was given to llama to answer this question. We have 7C, and we have brute force attack over here. Sweet. So it is a brute force attack in malware. Awesome. Let's ask a question giving it a file. So I have a file over here that has 2 hash numbers mentioned in it. So let's upload a file. Oh yeah, malware sample. Okay, so let's do one more test where give it a file, and we'll be seeing how Gemini reads the hashes, and if it can answer a question based off the report. So I have passed it a file. Let's use llama 3, and let's see. We have this file where 2 hash numbers mentioned. Let's ask it a question. Can you give me the MD5 hashes being used in this report? Let's see what Llama 3 tells us. Okay, the MD5 hashes mentioned in the report are to report, okay, 6165. Okay, yeah. These ones are the SHA-256, and it gives us two hash numbers of a different MD5 hash. And I've tested it out. These two are the correct SHA, or these two are the correct MD5 hashes. And this is a really cool thing because, for example, over here, if we see our CSV, we have SHA-256, MD5 hash. So a malware sample can be described in many ways. And using our malware rag, we are able to get relevant information just from a simple prompt. And in most cases, Llama gets the correct information from the embeddings and answers the question with relevant context that is correct.